Yeah, straight lines, quadratic equations, right? We're gonna have parabolas that look like up there on the screen. Have you guys seen parabolas before? Did you talk about them in geometry?
What?
Parabolas, like a U-shaped curve on a graph?
Yeah.
No?
Oh, I remember.
Parallel.
Thank you. Alright, so yeah. Guys, if we want to see our test, the talking's got it. Right? So, here's the deal. That is what our whole unit's based off of, is quadratic equations. They make that shape on your graph. All your I can statements are on the front of your note packet. Right? You should be able to say you can do all those things by the time the test comes around. Speaking of our test, we've not mapped out what day it's actually going to fall on. You'll notice it's a 10-day unit though. It's a pretty long unit. It's probably at least 2 weeks away from now. Alright, so it is a longer unit to start our semester. Some of the units coming will be shorter. And this is a longer one. What's that?
More stuff on the test.
I can't hear more
I mean, there's more stuff on the test.
More stuff on the test, yeah.
No.
More stuff you gotta learn, my man.
It's
Hard to fail?
It's harder to fail if there's more.
It's hard to fit.
Yeah, that's so hard to remember.
Alright. We're going to solve equations today 2 different ways, by factoring or by manipulating equations. Alright, so those are 2 ways we're going to do it. We're going to talk about a few other things as well. So what's a quadratic equation? A quadratic equation is an equation, I should say anything. It is an equation of degree 2. What that means is our largest exponent there is the second power. You'll notice all the linear equations we worked with last unit were all just x, right? There's no x squared, x cubed, anything like that. So linear is just an x. Quadratics are raised to a power of 2. That's what makes it a quadratic equation, right? Quadratic, quad. So you get square, squared exponent. Whoa, it all goes together. So, a square makes us a quadratic equation. Now, we're going to solve it in 2 separate ways. First way we're going to talk about is manipulating an equation. This is going to happen when we have just an x squared in our problem. So, what's going to happen is we need to get that squared term by itself and then take the square root to solve. So the first one, 2x squared minus 10 equals 40. Well, how would I get this squared term by itself?
Plus 10.
Add 10 to start, good.
Going.
2x squared equals 50. Divide by 2. X squared equals 25. How do I solve that? X squared equals 25. Will?
Square root.
Hey.
I'm so sorry. I said before you said his
Baby
name.
girl,
I'm
he said
so
Will.
sorry. I'm so sorry.
Square root. Square root it. What do you get for an answer? X equals
Positive -5.
positive and negative 5. Guys, in this unit, when you are solving, 99.99% of the time, you will have 2 answers.
Oh, really?
Yes, Calvin. 2 answers. We will see one opportunity today where it gives us 1 answer. But most of the time, like I said, 99.9% of the time, 2 answers. Right? Because both 5 and negative 5 squared will give me 25. Good, the second one. X minus 3 squared equals 16. Well, I already have my squared term all by itself, so I'm going to square root it to start. I get x minus 3 equals 4, or x minus 3 equals negative 4. Right? I take what's under that radical and that square piece and set it equal to both 4 and negative 4. Yes, sir?
Did you say plus and negative the number or no?
If for like this one, I would accept plus or negative 5. But like this, we're going to get 2 separate answers. We're not going to be able to use that. Yeah. So, add 3 to both sides. X equals 7. Add 3 to both sides. X equals negative 1. Those are 2 answers. Right, does that make sense?
Hold up.
So get your square term by itself, take the square root, you're going to have 2 parts come out of that, solve them both. Alright.
Solve them both.
What?
You have to get like that.
Yeah, you got to solve them both.
No, I'm talking about the other one. The
This one?
Green
Green one. Yeah. Have to equal both 4 and negative 4.
Okay. What
Okay?
if I just put plus? No, I can't. I mean, for the other one, can I just put plus minus? Fine.
Yeah.
Yes.
Okay, thanks.
Yep. Cam.
And the reason we say plus or negative is because we don't know what's a negative or positive, right?
Well, the reason we say plus or minus,
Yeah.
I mean, so you're saying like in this one, why we say plus and minus? Yeah, because we don't know. X could be positive 5 when we get 25. X could be negative 5 and we still get 25. So we don't know which one it actually is, but those are two possibilities. Good. And then the second method is if we have x squared and x, we're going to factor. Right? We're going to get one of our sides equal to 0. And the really important part is you always want a positive x squared. Knock it off.
Sorry.
We always want a positive x squared, but we need one side equal to 0. In this case, it's already set up for us. X squared minus 4x minus 12 equals 0. Right? Like I said, I have x squared and I have x. So I know I'm going to use this method. I'm going to factor. What multiplies to negative 12 adds to negative 4? Iman?
Positive 3? No. Wait,
Negative 6 and
Oh, negative 6 and 2.
Negative 6, positive 2. So I'm going to factor it. X minus 6, x plus 2. Okay. Does anyone remember the zero product property?
Nah.
Zero product property states that anything times 0 equals 0.
So x is good.
Right? Well, hold on. That means if this piece is 0, x minus 6 equals 0, 0 times x plus 2 is going to be 0, right? Anything times 0 is 0. So if x plus 2 equals 0, x minus 6 times 0 would be 0. So the way we're going to solve this is we're going to take each of these pieces and set it equal to 0. Because if one of them equals 0, that whole thing's got to equal 0, right? We're multiplying them. So then we're going to solve both of these. Add 6. X equals 6. Minus 2. X equals negative 2. And those are my two answers then. Notice we still got two answers. Alright, any questions on that? What? Huh?
How you gonna know what you said?
Alright, I'm moving on.
Wait.
Wait. Yep.
Okay.
I live in that jungle.
Hey. You're actually going really well. Andrew, you good? Thank you. Alright, so what does a solution mean? Because it's going to ask you, find the solution in this quadratic. Find the solution in this equation. It may also call it a root. It may also call it a 0. It may also call it, say, answers. Find the answers, right? Root, 0, solution mean the exact same thing. I can almost guarantee you, because I've seen this test before, that it may say on it in some point, find the roots of this solution of this equation, or find the zeros of this equation. If you're not paying attention right now, you're not going to know what that means when it comes test time, because you bring it up to me and be like, hey, what does this mean? And be like, sorry dude, can't tell you. So, zeros, roots, solutions, all mean the same thing. So if it says, what are the zeros of this function, I'm going to solve this the exact same way I just solved the other ones. Because zeros is the same as solutions. So it just has an x squared term, so I'm going to add 1. X squared equals 1. Take the square root. X equals positive 1 or negative 1. Those are my zeros, but they're also my solutions. They're also my roots. They all mean the same thing. X squared plus 6 equals 22. Same thing. Solve it for x. Subtract 6. X squared equals 16. Square root. X equals 4 or negative 4. You can write positive, negative 4 if you want. You can separate them into two separate ones. I don't care as long as you have both answers. Okay? Any questions? Okay, let's talk about graphs a little bit. We're going to get more into graphing, and we're going to show you how to actually draw the graph for quadratics probably later in this unit. But we're not going to do too much of it. Wonderful. Thank you. We are going to do that later in the unit. Today we just want to talk about how do you find solutions off of a graph. So if I have y equals x squared minus 1, right? I would draw that graph on there. So I'm just going to pick some random numbers for x. We're going to plug them in to find our y's. We're going to plot those points, okay? So let's say I'm going to let x equal negative 2. If x equals negative 2 and you plug that into this equation, what's negative 2 squared? Positive 4. Right? Negative 2 times negative 2 is 4. Do we all agree with me right now?
Yes.
Minus 1 is?
3.
3. Good. That's our y value. Y equals 3. So I would plot that point. Negative 2, 1, 2, 3. Then let's say I let x equal negative 1. Y equals?
What?
What's negative 1 squared? 1 minus 1 is? 0. All I'm doing right now, guys, I'm picking a random x value so I can graph this. So at negative 1, 0, plotting a point. X equals 0. 0 squared is?
0.
0, right? 0 times 0 is 0. Minus 1 is? Negative 1. X equals positive 1. 1 squared is 1, minus 1 is 0. So 1, 0. X equals 2. 2 squared is 4, minus 1 is 3. 2, 1, 2, 3. And that's how I'm going to draw this in then. So that's our shape. We will talk, like I said, more about graphing later in the unit. The important thing I want you to see is, when you are looking at a graph, if we give you a graph that looks just like that, and we say, hey, what are the solutions? Or what are the zeros? Or what are the roots? Right? All those words mean the same thing. You need to look and you need to tell me, at what x value does our graph cross the x-axis? Right? So we want where y equals 0. So we want it where x crosses the x-axis, where our graph crosses the x-axis. Excuse me.
I'm so confused on the bottom.
So if I ask you, Iman, solutions to this graph, you need to look and find where it crosses the x-axis. Which one's the x-axis? This one or this one? The one left to right, right? Where does it cross that? What x values?
Negative 1.
Negative 1 and
Positive.
positive 1. So x equals negative 1, x equals 1.
That's all you need to do.
That's all you got to do. So if we give you a graph, we say, hey, find the solutions. You got to look and see, where does it cross that x-axis? In other words, where is y equal to 0? Yes, sir.
Will the line be already drawn on the graph when we get it? Or no?
It might be. Now, we're also going to talk more in depth on graphing later in the unit. We just want to talk about how you find solutions off a graph. Okay? Alright, does that make sense?
Yeah.
Okay. We are going to skip the next graphing one, because like I said, we have a short time today, it's a shorter period. I'm going to keep going. Okay, so, solutions. How many solutions should we have? 2. Now, those 2 solutions could be many different things. They can be what we call irrational. Right? If I solve this, I subtract 2, I get x squared equals 10, and I take the square root of that. Is 10 a nice number? No. Do you think I want you to write a really long decimal or a rounded number?
No.
Absolutely not. We are going to use
The number outside.
the thing.
The number.
No, not you wait until we talk about imaginary numbers, then you bring that up.
Okay.
The,
Okay.
no,
The thing,
number
what's that
out-
thing?
The number outside the thing.
Not
The number
Okay, but x
outside
equals
the
irrational. That's
radical.
what you
The number outside the
vocab words.
The
Vocab.
X equals
the
Remember,
literal.
simplified radical form.
I used the word radical.
Right? Simplified radical. So, guys, hey, do we remember what that is?
No.
That's where we look and we see, are there any perfect squares that go into 10 as a factor?
1.
We don't count 1, because that doesn't do anything for us. It doesn't change anything.
Well, it is.
No! So we're just going to leave it then as positive, negative, square root of 10. Because I want the exact form. I don't want rounded numbers. That throws everything off. We want exact. Yes,
Anytime I
Iman?
get a decimal, I just say 9 and put that down in there and just answer.
Yes, except we'll see what at the end of the notes, where we're actually going to simplify it because it's able to be simplified.
See, math be contradiction in everything that they say. Like you do one thing, never mind. Don't just do it. I gotta find a new way to do it. Like just leave it. Just leave it.
Leave it for now.
That's for now.
For now.
Forever.
All right, the next one. Hey, we did that first semester. Imaginary numbers, hey, we used those first semester, didn't we?
Yeah, the I.
Yeah, so subtract 13.
The one
Eight
thing.
and nine.
Give them one thing.
X squared equals -9. Take the square root of that. Hey, if you put the square root of -9 in your calculator, what happens? Error, right? You can't take the square root of a negative number. Well, remember, what we did first semester is we made this x equals square root of 9 and square root of -1. Because what is -1 the same as?
I.
Not I,
I
but
squared.
I squared. And Iman, when you take the square root of I squared, we're going to get I. Okay, so we get square root of 9 and square root of I squared. Well, square root of 9 is? Oops, equals positive -3. What's the square root of I squared? I. So I get positive -3I. Now, if you can tell from -9, you can go right to positive -3I. If you do all the in-between steps,
Yeah, that's one.
you don't have to show these in-between steps. If you can skip over those and it works in your brain, do it. That's fine. But if you need to write those steps out, write them out. All right. And then lastly, we have rational, which are just our normal ones, plus 5. X squared equals 5.
Plus 4.
It's plus 4.
Thanks, guys.
X equals 5.
Appreciate it. Plus 4. X squared equals 25. Square root x equals positive -5. Okay, does that make sense? So we have 3 types of answers. You can have imaginary solutions, you can have irrational, or you can have rational. Alright? Cool? We're not looking at their graphs. We don't want to look at their graphs yet. Okay. I'm just super popular today. Hey. Alright. We're going to do 3 out of the 4 of these. So, all we want to do here, guys, is we're going to practice how do we get these equal to 0. The first one, x squared equals 3x minus 1, right? I have x squared and x. So if I'm going to want to solve this, I want to get it equal to 0. How can I do that? Do not say subtract x squared. Iman. What?
Solve it.
Not going to solve the x. I just want to get one side equal to 0. Yes.
3x and minus 1 on the side.
Okay, yes, so can I reword it? We need to get the 3x minus 1 to the other side. We can't just move it, right? So how do I undo positive 3x?
Subtract it.
Subtract it. X squared minus 3x equals -1. How do I undo the -1? Add 1, good. Now, I get x squared minus 3x plus 1 equals 0. That's all we're doing. We're not going to solve them yet. Alright, we're just trying to get them equal to 0. Now, why did I say do not tell me to subtract x squared? Why did I say that? What's really important about x squared when we do problems like this?
It has to be a positive.
It needs to be positive, right? Because if we're going to factor it, have you ever factored a negative x squared?
No.
No. So make sure you keep your x squared positive. Alright. Next one. Someone tell me how I can do that one. Not FOIL, but distribute. Good. Good. Thank you for using vocab words. Distribute.
Put the thing in the thing.
2w squared minus 4w equals 5.
What?
Well, once I've distributed, how do I get it equal to 0?
Subtract 5.
Subtract 5.
Nay.
I'm not going to do the nay.
You good?
You could, but it would look weird. It would look weird and you still wouldn't have it equal to 0.
Eliminate twice equals 0.
I don't think that's true. Why don't you test it out for us?
You gotta do it like off 2K. You know, hit the green.
Alright, last one. We're going to do the one over here, the fractions. Because you guys all love fractions.
Nope. I know.
You good? Alright. Hey guys, when you see fractions, we don't want to deal with fractions, right? So what we need to do to get rid of our fractions, we need to multiply by the least common denominator.
X.
which in this case would be, least common denominator here would be x squared.
Wait, what?
Right? So, you need to figure out what your least common denominator would be between these three and multiply everything by x squared then. So what's going to happen, watch what happens. I multiply them all by x squared, I get 5x squared plus x squared over x minus x squared over x squared equals 0. So when I multiply by the least common denominator, I'm able to simplify these, and I'm going to get rid of all my fractions. 5x squared plus, what's x squared over x?
X.
X minus,
Nothing.
don't you dare say nothing.
X squared, right?
X squared over x squared is equal to 1, right? Same thing, top and bottom is 1. So minus 1 equals 0. So if you're dealing with fractions, we don't want to deal with those when we're trying to solve these. Multiply by the least common denominator, gets rid of your fractions, and you can go from there. Okay? Cool?
Yeah.
Alright, I'm out here tonight.
37.
Kelly, you lying to me? Alright, we need to do a couple solving and then we'll go to our test. Cool?
Sure.
Alright, so let's try some examples. Let's do 3 examples. 3 of them. X squared equals negative 6x minus 9. Cam?
Add 6x, add 9.
Good, right? Because we have x squared and x, we want to get it equal to 0 on one side. So add 6x and add 9. I'm going to do it in one step. Is that okay with everybody?
Yeah.
Is that cool if I do it all together?
Yeah.
Okay. X squared plus 6x plus 9 equals 0. Awesome. So once we got it equal to 0, what did we say our next step was?
Least common denominator, right?
What's it?
Least common denominator.
Not least common denominator. That was if we had fractions. So we're in standard form. We have it equal to 0.
Factor.
Factor it, right? Let's factor it. What multiplies to 9 adds to 6? 3 and 3.
That's supposed to
You
be.
get 16 extra.
Plus 3. X plus 3 equals 0. So factor it. X plus 3, x plus 3. What are you talking about 16x for?
I see 16 X.
6x?
That's a 6?
That's a 6, man.
No, the one above it.
Add 6x, add 6x.
Oh, I see 6.
Because your plus didn't go
Oh,
all the way to the
he's
line, so
signing
had me
up.
confused. I'm like, what is
There?
that? Thank you.
Okay.
I'm like,
Alright.
man, 16.
Once I've factored it, guys, set each piece equal to 0. X plus 3 equals 0. X plus 3 equals 0. Solve them. Minus 3, x equals negative 3. Minus 3, x equals negative 3.
Is that the one you're talking about?
This is what I was talking about, right? If it factors to 2 of the same pieces, guys, you're only going to get one answer. Right? Because both x's come up to the same thing. So this is that 0.01% of the time where you're going to get one answer instead of 2. Okay? Alright?
So you don't have to write.
You don't have to write them both. Nope.
Yeah, because
So if, as soon as you get to here, you notice, hey, these are the same, all you do is solve one of them. Alright, next one, x squared minus 5x equals 0. Well, I have x squared and x,
You know what I mean?
so I'm going to get it equal to 0. It's already equal to 0, right? So I'm going to factor from here. What do I factor from here?
Reality just
I don't know.
I'm not going to factor into 2 pieces, am I? Like 2 parentheses. But what else can we factor? G, C,
Greatest
F.
Greatest common
Greatest
factor.
common
A greatest common factor. Do they share a common factor in here?
X.
Yes.
X. So x times x minus 5 equals 0. Now, the same thing I did over here after I factored, I'm going to set my first piece, which is just x, equal to 0. And I'm going to set my second piece, x minus 5, equal to 0.
X equal to 0.
Solve them both.
X equals 0.
We should get x equals 0 or x equals 5. 2 answers.
Yeah.
Alright?
That's a really straight line. That is a straight
Any questions?
Yes.
One more. What's your question?
fight.
Hold on, I'm just looking at it for you.
Okay, while you do that, we're going to do the last one. So we're going to skip the next 2, we're going to do the last one.
Oh, you split down? How am I going to see
Well, didn't you write it down?
I didn't, so I was trying to figure it out.
Alright, I'll go back to it when you go through a test. Okay? Alright. Do I have x squared and x in this problem?
No.
No, I have just a squared term. So I'm going to get that squared term by itself by subtracting 10. X plus 4 squared equals 200. Well, once I get the squared term by itself, I normally take the square root, right? Okay, so square root, x plus 4 equals,
20.
is square root of 200 a nice number?
No.
No, it's not. So we need to do simplified radical form. Simplified radical form would be, is there the perfect square that goes into 200?
Yes.
Yeah, 25 does, but I want the biggest one. 100 does. So what I'm going to do is I'm going to take 200, split up into square root of 100 and square root of, what's 100 times what? It's 200. 2. Square root of 100 is 10. Square root of 2 is not a nice number. So when I do simplified radical form, I'm going to get 10 times the square root of 2. So x plus 4 equals positive 10 square root of 2. X plus 4 equals negative 10 square root of 2. Right? We need to set it equal to both the positive and the negative, what it comes out to. Does that make sense? Simplified radical form. Alright, and then last thing you need to do here, minus 4. X equals negative 4 plus 10 root 2 minus 4. X equals negative 4 minus 10 root 2. No, you absolutely cannot do negative 4 plus 10 or negative 4 minus 10. Why can't you do that?
Because that's its own thing.
It is its own thing, right? And if you think about order of operations, I have multiplication here. Can I do that before addition?
Yes.
No.
No.
Or can I do addition before that? Sorry. You were right, I said it wrong.
Yeah.
Can I do addition before the multiplication?
No.
No, so that's why I can't add or subtract those, that's my final answer. Alright? Any questions? Sweet. Swipe up. Subscribe.
Go back to the one question.